7.1 part 4. We're dividing rational expressions. We need to get these as factored as possible. These two do not factor. For this, we look for GCF. Top and bottom, I don't have a GCF in either one. I have 3 terms, so I look for squares on the ends, and I do not have perfect squares. So for each of them, I'm going to be needing 2 numbers that multiply to my last number and that add to my middle number. And on the second one, it's going to be multiply to a 3 and add to a 4. Things that multiply to 2, 1 and 2. Now I need to multiply to a positive, so they're either both positive or they're both negative. I need to add to a negative, so that means these two need to be negative. Double check your arithmetic, and that works. So the top will factor as z minus 1 times z minus 2 over. Multiply to 3. Well, the only things that multiply to 3 are 1 and 3. Add to positive 4. 1 and 3 are going to work. So this is z plus 1, z plus 3, divided by, recopying here. Okay, now that everything's factored, I can change it to a multiplication. Z minus 1 times z minus 2 over z plus 1, z plus 3, times z plus 1 over z minus 1. Okay, now let's look for cancellations. I don't have anything up and down here. I don't have anything up and down here. But on the diagonals, I have a z minus 1 and a z minus 1. So those will cancel out, leaving a 1 down here on the bottom. And on this diagonal, I have a z plus 1 in each of them. So that cancels out. The only thing I have left is a z minus 2 in the top and a z plus 3 in the bottom. And that's as good as that one gets. That's reduced. Okay, so I like to work problems that are as ugly as they get. And this is about as ugly as they get in this section. We have a multiplication where we're going to have to factor a lot, and then we have a division. I'm going to start off worrying about these, and I'm just going to let the division follow us along until we're ready to use it. I need to factor all through here. For this one, I do not have a GCF. I'm looking for, I don't have a perfect square here, so I'd be looking for 2 numbers that multiply to a 32 and that add to a negative 12. Well, things that multiply to 32 would be 1 and 32, 2 and 16, 3, no, 4 and 8. 4 and 8 is going to work, right? If I make both of these negative, they multiply to positive 32 and they add to negative 12. So this first one here factors as m minus 4 times m minus 8. And this is over, there's nothing we can do here, 8m, just stays there, times. Okay, for this one, I have an m in each of these, so I have a GCF. I'm going to factor out that m, and it leaves me with m minus 8. Okay, so that's factored. Let's look at the bottom here. There's no GCF. I have 3 terms. I do have squares on the ends. 16 is a perfect square. The square root of m squared is m. The square root of 16 is 4. If we multiply these together, we get 4m. If we double that, we get 8m, which is exactly what we have right here. So this is a perfect square trinomial. This factors as m. That's a minus sign, so this is a minus sign. 4 squared. And this is divided by, I'm going to go ahead and put these in parentheses, but they're just going to follow us down for a little while. Okay. Now let's look in here and see what we can do. There's nothing in this that cancels up and down, There's nothing here that cancels up and down. But on our diagonals, if we look here and here, I have an m minus 4 here. Remember, that's to the first power. M minus 4 squared. This 1 cancels out one of these, so I still have 1 left down here. On this diagonal, I can't cancel out the 8s because this isn't an 8, it's an m minus 8. It has to work as a unit. But right here, I have an m in each one, and I can cancel that out. So just look at what we have here. We have m minus 8 times m minus 8. That would be m minus 8 squared over 8 times m minus 4. That's what I have left from this big set of parentheses. And I want to divide m minus 8 over m minus 4. Now we're ready to do that division. Keep it, change it, flip it. Change it to multiplication, flip this one. All right, and now look for cancellations. Here I have m minus 8 squared. Here I have m minus 8 to the first power. This 1 cancels out one of those. So I still have an m minus 8 in there. Here, I have an m minus 4 in each of those. So I have a 1 here and a 1 here. All I have left is m minus 8 over 8. As tempting as it is to cancel out those 8s, you cannot do that because this whole thing would have to cancel out. M minus 8 has to work as a unit. Keep it in parentheses if it helps you remember that, but it's critically important.